Hello and welcome to the first lecture in CIS135db database theory. And what I hope to accomplish in this lecture, it'll be a little bit of a rehash of Simon Allard's video on YouTube that I had you watch on Foundations of Programming. Before we get into SQL next week, we should know what is a database and why they're important to use. And so basically the agenda is to do just that. What is a database? Why do we need one? The advantages of storing information in that database, and then we need to cover some terms, the components of a database system, so that we're all talking the same language. Before we get into that, just a reminder of what's our goal for this course. And if you remember, I've talked about this in the course introduction video, but basically we need to be able to describe the purpose and importance of a database. Well, that's kind of this week's lecture. We want to understand database terms. When we talk about databases, it comes with its own language. Whoops, I didn't mean to do that. Come back. So anyway, a lot of these terms will come out this week. A lot of them will come out in the next 9 weeks. The majority of the course will be spent learning SQL, the structured query language. Next week, we'll start doing data definition, DDL, which is create statements, drop table statements, things like that. And then from that point on, we'll start doing the data manipulation language, is how we insert, update, and delete information. And at the end of the term, hopefully you're going to be pretty good with the MySQL database management system, and then we're putting this MySQL Workbench front end on it. Now remember, this week's goal is to get both of these installed. We get into week 7, 8, 9, somewhere in there, we'll start designing a simple database, and then we'll create this thing called an ERD diagram, entity relationship diagram. So that's what we're doing for the entire term. This week, we want you to be able to recognize the problems with putting data in a spreadsheet, because it can be done, but it does create problems. So then that gets into, well, why do we use a database? How do we avoid those problems of putting information in that spreadsheet? What are the components of a database system? And then what are some of the elements of a database, right? When we talk about tables and records and columns and fields and attributes, you need to know what all that means. We need to understand the purpose of a database management system, DBMS. Find the functions of a data, or identify the functions of database application, and finally, this week, you should be able to install MySQL and MySQL Workbench on your computer. So basically, the purpose of a database is to keep track of things. How easy is that? Organize, store, and retrieve data. What kind of data? Literally could be anything from dates, pictures, audio files. So when you go out to Spotify or Amazon's music service or Apple's, right? You request all the tracks by a particular artist, well, you're actually hitting their database of those audio files. The same thing if you go to a picture website. So the data is, the kind of data you can store is unlimited. It's just whatever you need to store and keep track of. And the answer, then Simon talked about this, why not use a spreadsheet? Actually, you can. A lot of small businesses will do that. They don't know databases very well. They know Excel. So they'll start tracking their data in Excel. Eventually it leads to problems. Excel is good at analyzing data. That's not really meant to store and keep track of things, although a lot of small businesses will use it in that way. So what issues do you run into if I were to store information in a spreadsheet? So again, this is a rehash of what you should have listened to in Foundations of Programming. But real quickly, the size or the amount of data, if you start, a spreadsheet can handle 10,000, 100,000 records, but you start getting more than that, and it becomes problematic. They're not really designed to deal with, I feel like you're a Facebook or an Amazon or Google, where you're just storing terabytes of data. You need to have a database. And even once you start, like I said, a spreadsheet, you can put 100,000 records into it, but that's not how it's meant to be used. Ease of updating. Obviously, spreadsheets are typically used by one person at a time, where a database is meant to have hundreds of concurrent users. Databases are designed where you can put really infinite controls on exactly what I want to see in each column, and not allow people to put something different into those columns. And a database has security features built in where it'll automatically back up the information. I can control who can see what records, even who can see what columns are in those records. And a lot of times, or all the time, they'll have a transaction logging. So every time something gets changed in the database, it keeps a little log of who changed it, what was the old value, what's the new value. And a database, if designed right, eliminates data redundancy, right? And this data redundancy leads to these anomalies. So some of that might not have made sense, but let's take a look at some examples. So here's a spreadsheet. Hopefully you can see it in this video because I know it's just a picture and it's kind of small. But for instance, without some data controls, here's somebody's put SOCal Windows and here they've spelled it out. Are those the same company? Is it a different company? Right? Why do I have that twice? Also, notice I have order number 124, but twice. Well, theoretically, each order is unique. So I shouldn't have order 124 twice. So I end up with duplicate values, right? All of a sudden, for this Southern Cal Windows, I'm not producing any product, so the product isn't listed. Well, is that because it's a new company and they don't make any? Did I forget to put it in? Why is that missing? It's unknown. And when data is missing like that, you'll hear the term null. That's a null. Some people will complain when you say null value because it's not even a value. It's just null. It's blank. It's missing data, and you don't know what it means when data is missing. Also, as I mentioned about data controls, right here you have a 26% discount, and it's suspicious. Is that really supposed to be 26%, or did somebody mistype it? Another issue with a spreadsheet like that is what if I wanted, notice how they list the products, comma delimited, widget A, comma C, comma D, widget B. I want to do a query or ask the question, who are all the companies, show me all the companies that produce widget B. Well, in a spreadsheet designed like this, that's kind of hard to find because it's buried in a list of products, right? And so putting information like this becomes problematic because then when I go to ask questions about the data, it's hard to get the answers back. So what are the issues with the spreadsheets? Well, you end up with data modification problems, okay? So there's three types of problems, and sometimes you'll hear the word anomalies. There's a deletion problem, okay? So if I put data in a spreadsheet, if I delete a piece of the data, I accidentally delete other things that I may have wanted to keep. And down here, I'm gonna bring up an example for you. There are update problems, okay, where basically if I'm trying to fix something, somebody gets married and changes their name, or there's a change of address or a change of department or whatever, I may not update all of the records, and then I end up with that inconsistency that I showed you in the previous example. And finally, an insertion problem. I just want to add one piece of information, well, it leaves all the others blank. So let's pull up an example of that. Okay, so then take a look at this spreadsheet. I'll zoom in. Oops, hopefully I won't run off the end here. But let's say I have a list of students, their address, city, the county they're from, state, zip, phone, right? Information about students. There's their email right there. And then I put next to the who is the advisor for that student, what department do they belong to, and then the department admin. Well, what if Bernard LeBoy, who's right down here, decides to leave school and I want to remove his record? Well, if I delete row 7, all of a sudden H. Smith, my advisor, and he, by the way, is only advising one student, is gone. So in my spreadsheet, all of a sudden I've lost track of one of my advisors because I happen to have deleted a student. So that's what we mean by deletion problem, okay? Same thing, what if I have a new advisor coming on campus, right? And so I put their name over here. I'll just put my name, right? And then I would fill in my address, my department admin. Well, all of a sudden, all of the rest of this is blank because I'm not advising any students yet, right? And so remember I mentioned blank or null fields are a problem because you don't know why they're blank. Is it because I'm not advising? Did somebody forget to do it? Have we not asked yet? You know, why are these blank fields? So that's what we call an insertion problem or an insertion anomaly. All right, and finally, here's the update problem. What if Jay Baker, his department is in error? Right? Well, first, let's say he switches to the chemistry department. I have to find every instance of Jay Baker. and get that switched. Which, to be honest with you, that's not that hard in Excel. You can do a find and replace. But the other issue is, well, if he switches to chemistry, then I have to remember to switch his department admin, right? All of a sudden that field is wrong. And what if we have the admin phone number over here? Then what if, right? So then how many fields do I also need to change? So that becomes an update problem. And so right there, these three examples are what makes putting data and storing data in a spreadsheet problematic. In addition to that list we showed a few slides ago about size and security and some of those other things. But it's in essence storing two different themes of data. I've got student data and advisor data. And when you start in combining combinations like that, combining information from two different categories or themes, I'll use that term, becomes problematic in using a spreadsheet. Also on this slide, I have a link, and I'll just click it and show you, but they will, if you have some questions about these anomalies, this will also describe it and give you another example, very similar to mine example. But anyway, in your own time, you can click on that link and read that. So, addressing the information complexities, right? Storing information in a spreadsheet, or sometimes this is referred to as a flat file, is problematic, and that's why relational databases were designed, to address some of those issues. So for every problem that we listed a few slides ago about too much data, the lack of control, large number of concurrent users, well, that's what database systems are handled to design, or designed to handle. I said that wrong. If a database is designed right, they can handle large amounts of data. We don't end up with redundancy of data. We're able to do inserts, updates, and deletions of data without causing problems. So a relational database basically stores information in what we're going to call tables. And funny enough, a table looks like a spreadsheet, right? It has rows and columns. But each informational topic, so for instance, students and advisors, is stored in its own table. We don't create one ginormous table, or else we might as well just use up a spreadsheet again. So we're going to break up a list. You can use the word list or spreadsheet into several tables, one for each theme in the list. Again, we kind of already mentioned that. The database consists of one or more tables. By the way, without a table, you don't have a database. You need at least one. And some terms. The fundamental components of a table. So those you can have columns, obviously, are the things that go up and down like a column of a building. But sometimes you may hear those called fields. Or when you're designing a database, sometimes you call those attributes. What's the attribute of a student? Well, they have a first name, a last name, a city, state, zip, right? Those are attributes of a student, okay? It's a property of the information that's being stored. And then in your table, you have a row. Well, sometimes that will be called a record, or in rare instances, or in really scientific circles, you may call that a tuple, T-U-P-L-E, and that's just a single set of columns. Okay. Now, when you create a table, unlike a spreadsheet though, we need a way to uniquely identify each row. All right. And a lot of times we just put a number next to each row, and we call that the primary key because it's going to uniquely identify each row. And then what we're going to do later is relate that table with another table, and we'll use that primary key in another table, and at that point it becomes a foreign key. In a couple minutes, we'll give you some examples of that. I'll give you an example where we're going to take a spreadsheet, we'll break it up into several tables, we'll assign a primary key or unique identifier to each row, and then we'll join those things back together again. Okay, so let's go back to our example of the students. Now remember, I have student information here, and then I have advisor information, and then the department, all right? And by the way, notice like the advisor information is redundant because J. Baker has 2 students, or R. Valdez has 2 students, B. Tang has 2 students. How about the accounting, right? There's 2 advisors, Tang and Baker, in the accounting department. So I list accounting and the department admin 3 times, right? Well, what does this look like if we were to put it into tables? Basically, we would end up with a student table that has nothing but information about the students, right? And then in this blue column, I just randomly assign numbers to them, 1, 2, 3, 4, 5, 6, 7. It could have been 100, 200, 300, 400, 500. It could be anything. It just has to be unique for each student. All right. And then notice I did the same thing right here for the advisors. Right. Now I list each advisor one time. Baker is listed one time, and the same thing with departments. There's the accounting department, but I list it one time with their admin. And in each case, I assigned a unique number, right? And it's at the random number. This one has nothing to do with that one. It's just a one in this table that uniquely identifies that row. All right. So then what I do is I use that primary key, unique number, and I show it over here in this table. So J. Baker belongs to the accounting department, and so does Tang. And I can tell because of that one sitting right here in this table. Valdez belongs to chemistry department, and Smith belongs to the math department. So how about students? How do I know who their advisor is? I use this number as the primary key. Over here, where now it's called a foreign key, and so number one is Baker. So this student has Baker as his advisor. Number two is Valdez. So Raud Cruz has Valdez. R. Valdez is his advisor, and so does Rose Feifel. Okay, so that's taking that one spreadsheet where things are listed multiple times, and we end up with these deletion, insert, update problems. And over here, I break it up into 3 tables. So now guess what? If I want to add a new advisor, all I have to do is put it right here. If he's not assigned any students, that's great. Who cares? I can assign his department number. If I need to add a new department, I put it over here, and it's not affecting. I don't end up with all sorts of null values over here, right? If I need to delete that student, so all I have to do is delete Bernard Leboy, but my advisor H. Smith is still here. I don't lose that. So that's the beauty of taking a spreadsheet with multiple themes of information in one spreadsheet and breaking it up into tables. It avoids the redundancy and those insert, update, and deletion problems. All right, let's do another example. Hopefully this will show up okay in the video. If you can see this spreadsheet, and basically what I have is, didn't do that, I can't click on the screen. Projects, who owns that project, and the things that were purchased for that project, the price, and finally the supplier and the discount that we get from that supplier. Okay, so this is maybe you're a small construction company, you don't know databases, and you're like, all right, every one of my projects, I need to keep track of all my purchases, who I got it from, and how much I've spent. And so they do it in a spreadsheet. Obviously, that's going to be problematic. Because now what if Elizabeth changes her name or whatever, and I have to update all of those records, or changes her phone number? What if I have a new supplier, but we haven't bought anything from them yet, right? So all those anomalies that we've talked about. So if I wanted to put this into a relational database, here's what it would look like. I would create a table just for my projects and who owns them, all right? And realistically, you could probably even put the owner and the phone in a different table. But let's just keep it simple. I'm going to give it a unique identifier, just a random number. Down here is a table where I'm keeping track of my suppliers. These are currently my 4 suppliers and the discount they offer us. And again, I just assigned a unique identifier. And finally, this table is nothing but a list of items, right, that we tend to purchase and what category they belong to: electrical, exterior, interior. And I've assigned them a unique number, and notice that number doesn't happen to be 1, 2, 3, 4. It's a little bit bigger. So again, what you assign as your primary key really doesn't matter. What matters is that it's unique. Finally, so for which project, what did I buy and from whom? You kind of have to know right here. In this table, they become all foreign keys. So we have a quote ID. That's the primary key. It's just a random 1, 2, 3, 4, 5, 6, right? But for project 1, right here, item number 1100 is the 200 amp panel. The supplier was Northwest Electric, and then the rest of the information. We bought one at this price for 170 bucks. Okay, so if I asked you what is the name of the project that bought a 50-watt breaker, how would you solve that? Oh, you'd have to run over here and go, oh, a 50-watt breaker is 1200. All right, so who bought 1,200? Oh, this guy did. So that's project one. Well, project one is the Highland House. So did anybody else buy it? Nope, I don't see any other. Oh, yes, sir. Right here's a 1,200. That's the 50-watt breaker. What project is that? It's number 3. 3 is the Hue remodel. So that's taking that spreadsheet and breaking it up into tables that we then put into a database management system and have a nice database that doesn't suffer all of the problems of a list or a spreadsheet. So now you're probably thinking, wow, that sounds like more work, not less, right? It's easier to keep information in a spreadsheet, and the answer is you're right. At the beginning, it's probably easier, and especially if you don't understand databases and you happen to know spreadsheets. But in the end, it's a lot more work and a lot more problematic to have information in a spreadsheet. Okay, so what you need to remember is that we minimize data redundancy. I'm not listing people's names 10 times. I list it one time in a table, and if I need to fix it, I can fix it there. And I believe this quote I got from Simon's video, but you're looking at the advantage of the security, the data integrity, that I can put controls on the data. I can query it easier. If you remember the example where how do I figure out who produced widget B? If you design your tables right, that's an easy question to answer. Okay. Also, relational databases, and we'll talk about that in a few minutes, provide a way to generate reports, and I can write applications against them much easier than I can spreadsheets or lists. So it allows me to create a lot more sophisticated of a process or procedure. Well, that's not the right word. It's a sophisticated system that many people can use. One thing I'll throw in here, we talk about data integrity, and you may hear that Simon used this word, structured data. And what we're talking about, okay, remember I'm creating a table and it has columns, sometimes referred to as fields or attributes, and then I have rows. And a row is information about, and these are examples, like this could be a customer table. So this row represents one customer, or this row could represent one project if this were a project table. Next week, you will see that when we create a table, we have to define exactly what goes in every column. And if somebody tries to put something that doesn't meet our definition, right? They're trying to stick a piece of text where I'm expecting a big number, the system will not allow it. If they try to put in text or a picture or a number in a column that I said must have a date, then the system won't allow it. So that's what we mean by structured data. And one way to achieve data integrity in our database is we define exactly what we want in every column. And then if something doesn't match, it will not be allowed. In a few minutes, I'll also get into constraints that we can add. I can even go so far as I want a small number, but it has to be in this range, between 10 and 20. In a database management system, I can even define it to that point, what the size of the number must be, or what the text has to be, or another one is a unique constraint. Whatever goes in this column has to be unique. It can never be duplicated in that column. Okay, so let's do one more example of taking a spreadsheet. So you're running a small art school. And same thing here, I've got customers, okay, and their phone number, but I also have the date of a course, how much they've paid for that course, the name of the course, and then how much the course cost. So for instance, Ariel Johnson paid $250 and the course cost $500, so she still owes us $250. Now again, you can see this is a spreadsheet, but do I have more than, and I use the word themes, more than one type of information in here? So kind of intuitively you go, well, I got customer information. I have course information, the course, when it's offered, and then the fee. And then really I've got customers taking courses, all right? So for instance, if I want to add a customer, just so that I can call them and keep track of their phone number, but they haven't taken a course yet, that's problematic, right? Because then I'm going to end up with all these blank fields over here. So if I want to turn this into tables, and by the way, we'll spend a lot more time doing this in I think it's week 8. That's part of how to design a simple database. We'll talk about how do I take this information and convert it into tables. Right now, I'm just showing you the results. I'll show you the process in week 8. So here's what the results look like. I mentioned I have a customer table, and there's my unique identifier. I just randomly assign numbers to it. I'm going to have a course table. These are my courses and when they're offered and how much they cost. Okay, so now these customers can take many of these courses, and of course a course can have many customers. So we're right here. Course number or customer number 1, Ariel, has taken course number 1 and she's paid $250. All right. Oh look, Ariel also took intermediate pastels, and she paid $350 for that, which was the amount of the course. Anyway, so you get the idea. This is our enrollment table, so I can see which customer took what courses. Who else took advanced pastels? Well, you run down here, and customer 3 did, and customer 4 did. So Jackson and Pearson. And by the way, the rest of the quarter, or a lot of the quarter, we will be talking about the language that helps us answer those questions. Show me all the customers who've taken advanced pastels on 10-1, and that language is called SQL. So at this point, I'm hoping you're clear on why using a spreadsheet is problematic and are able to tell me the advantages of putting the information that was previously in a spreadsheet into tables. What problems does that solve? Some of the advantages of a database over a spreadsheet in terms of your security issues, the number of concurrent users, the amount of data that can be handled, right? All of those are advantages of a database over a spreadsheet. Now let's talk about the components of a database system.